Hello, GoldSim users. The I want to share a model with you that allows me to demonstrate two different ways of representing flows between ponds. This kind of setup is very common in mine water balance models and water resources models alike. What we often see users doing is explicitly defining a flow from one pond to another. There is nothing wrong with that, but sometimes, depending on how the system is set up, it becomes very difficult to visualize how the flows are moving from one pond to another, especially in a larger model. So what I decided to do here is set up a very simple model with just two ponds, but the concepts can be applied to much larger models. I have set up this model that will allow me to define a flow from pond 1 that sends water from pond 1 into pond 2. And what I'll do is I'll start by showing you an example that is not conducive to a visual representation of flows, followed by a better representation. So to start off, I'm going to define an expression that is essentially the flow rate moving from pond 1 to pond 2. So both of these ponds are very simple. They both have a natural inflow and a natural outflow defined in a similar way that you would see in a real model, except that I've removed all of the messy details of calculating um, these natural inflows and so forth. I've just used some stochastic elements as placeholders. These are just essentially random numbers that represent flows coming in. Then I've defined some outflows that represent seepage and evaporation losses, which are just a function of the volume that are in the ponds. In addition to that, pond 2 has a maximum capacity, and when that capacity is reached, there is an overflow sent over to pond 1 with a delay. We use a delay to avoid any recursive loops in this model. Okay, so what I want to do now is I want to add another flow that sends water from pond 1 over to pond 2 on a regular basis, or on a more regular basis, if pond 2 is low. So the first thing we want to do is determine if pond 2 is low, and that's already being done. I'll navigate into pond 2 to show you that logic. When I go in here, you can see here's the pool element representing the amount of water. Also, here's the overflow being sent back to pond 2, and here's our natural inflow. Below this is our status element. This is what we're using to determine whether or not the pool needs water, whether it is low. And we do that by comparing the current volume of water in this pool to a target. Our target, if I hover over this element, you see is 100 cubic meters. So what we need to do is we need to trigger or flip a switch when the pool drops down below this target. It turns out we also use a deadband, and that's just a way to prevent rapid oscillations. But I also need to make clear here, and this is not really part of this presentation, but it is very important, and that is that a status element is used to help us decouple our flow request from the time step. If you just use an if statement, then you can easily get into a situation where you have rapid oscillations, and it is going to be a function of your time step length. So let's avoid all of that just by using a status element. So this status element has an output of either true or false. If it's true, it means the pond is low. If it's false, it means it's above the target and there is no need for extra water. Okay, so what we want to do then is we want to use this output of the status element to define our expression for calculating the flow from pond 1 to pond 2. It's very straightforward, and here's the expression written down below. So what I'll do is I'll add a new expression element here, and I will call this pond 1 to pond 2. And this is the flow from pond 1 to pond 2 if pond 2 is low. Okay, so I will put in here units. I have to make sure the units are compatible. These are flow units. And now let's just go ahead and write this if statement. If, and it's similar to what you're seeing below in that expression, if pond 2 dot volume, oh yeah, I don't have this outflow defined yet. So I just need to right click, insert link, drill into pond 2, select the element that I'm interested in, pond low, click OK, and now what it will do is it will expose this output on the container. Um, so now it knows what that is. Then I put a comma. I can also say um, then, if I want to. If the pond is low, then we want this flow rate to be the pumping capacity from pond 1 over to pond 2. Well, what is the pumping capacity? It turns out I already have that built into this container. You can actually see it over here in the browser. If you look into pond 1, you can see that there's this element called pump capacity. So I'm going to refer to that from pond 1. If pond 1 dot, there it is, pump capacity. It turns out this is already exposed output. Then I have my else statement, and the else statement is going to be 0 cubic meters per day. Okay, so that's pretty straightforward, but there is a problem with this, and that is, what if the volume in pond 1 is, well, let's say the volume in pond 1 is less than the pumping capacity that would be occurring over a full day, because I have a 1-day time step in this model. So I mentioned earlier that I'm trying to decouple my expressions from the time step, and here I am kind of coupling it with the time step. That is true, but this is a good way to prevent us from trying to remove more water than we can than is possible from that pond. So instead of just referring to the pump capacity, I'm going to put a min function in here. So min, that's a built-in function, gold sim, and I'll say min the pumping capacity, comma, pond 1 dot pool. So the amount of water divided by 1 day. So there's the expression. Same thing we have down here. So this will be the amount of water that is removed from pond 1 over to pond 2. And this is what I am seeing users do sometimes, is defining flows in this manner. And this is explicitly defining the flow. So this is the flow rate. This is what they want to represent as the flow rate. So because this is the flow rate, then all I need to do is go back to pond 2 and bring that water in there by referencing this element. So I'll go ahead and do that now. Go into pond 2, go into this pool, inflows, and now it turns out I already had a reference there. I gave it the same name, but if you want, I can remove that so I can demonstrate how I add that um, if it wasn't there already. It turns out I had it there before I did this presentation. Okay, so I'll go back into the pool, go to the inflows tab, add a new inflow, and that is the pond 1 to pond 2. So I add that there, and now you can see that the input port is showing that we have information coming from the outside. And I go back up, and now you see that we have this reference here. Okay. Also, we have references going the other way as well, and that is, if I double click on this, you can see that this is also influencing the request, a request on pond 1. So that's something that I did previous to the presentation I need to show you. That would be something that you would also need to do. You need to go to pond 1, go in here, and go to the outflows and make sure that you remove the water that you're asking for from that pool. Okay, so this works, and the reason it works is because of this little key part right here, the min function. Thanks to the min function, uh, this amount that we're specifying shouldn't ever exceed what is possible to be removed from that pond. However, what I see oftentimes is in more complicated models that it is a little bit more complicated than just saying it's a min function of these two things. Sometimes there's other things involved, or there's a and maybe an allocation process or other competing demands involved as well. So um, while it works pretty simply here, it can become much more complicated in a bigger model. But already what you're looking at right here is still, it's very difficult to understand what's going on just looking at this diagram. It's hard to know, where is the water going? We can see where the overflow is going, but it's hard to see if there's water moving from pond 1 to pond 2 or vice versa. It's hard to tell because there's arrows going in all directions. So my suggestion here is to alleviate this problem by separating requests from the flows. A request is just information. That's all it is. It's not a flow. And we should define a request. So how do we do that? Well, it's a similar way that we're defining this flow rate, but a little bit different. What I'm going to do is I'm going to imagine that in the real world that this pond has a SCADA system. There's a monitoring system. Let's say it's monitoring the water level. In our case, we have a very simple model. We're not dealing with water levels. In your model, you probably are. But in the interest of time, I'm just going to be monitoring the volume for now. But let's pretend like we're monitoring this water level and we have um, a telemetry system that essentially will send out a signal over to pond 1 and say whether or not it's low or not. Maybe it's just a 1 or a 0 that gets sent over via radio or something. And that signal is going over to pond 1. I want to mimic that signal by putting an expression into pond 1. So I'm going to go ahead and just do that. I'm going over here to pond 1, and I'm going to mimic that in terms and call it a request. Okay, so I'll do it with um, a selector element. I'll add a selector here, and I'll call it pond2 request. So this is a request that's being made. It's just information that's being passed over, let's just say through some sort of SCADA system. Okay, so I put cubic meters per day. That's the flow rate that we're going to be requesting. And I'll do that by referencing that information that we're passing over from pond 2. So that information is the pond low. That information comes over here, and if I close that for temporarily, come back up to this top level, then what you'll see is that there are actually two lines being passed over from pond 2 to pond 1, and it's no longer just this overflow moving over here to pond 1. There's actually two things coming over. It's overflow and information. Um, so that's something that we'll have to think about, by the way. But it's essentially overflow and info. I'll just say and info for now. Um, but those are the two things that we're passing. If we double click on this line, it shows here's the overflow, and there's this pond low information that's going over there as well. If we wanted to avoid that complexity right there, then my suggestion would be to then um, have this selector outside, or even better, in my opinion, would be to have this overflow passed or moved out. So I'm going to do that. I'm going to move the overflow out here so that it's very clear to everybody outside that we are delaying the overflow. So now that means I need to relink because we have the localized containers. So I'm just going to relink the overflow again. So this is pond 2 overflow coming over here, and this is going to be now low signal. Maybe that's not the best terminology, but that's what I'll use. And I want to pass now this overflow back into the pool inflow again. And you can see that link is now corrected. Oh, no. I want to actually link it to the overflow that's sitting right here. And just to be clear, here on the main level, we may want to call this pond 2 overflow, but because of the way that um, our influence lines are pointing, it does make it very clear, um, that where this overflow is coming from. You can see that the overflow is coming from this pond and then going into that pond. And now we have this low signal that is being passed separately. It makes it very clear. We're passing the signal over here to pond 1 to tell them something. Okay, so now we come back into pond 1. Now we can finish this logic here. So the information that we're passing is that the pond is low. If the pond is low, then we want to go ahead and pump at capacity. Pump capacity, otherwise it will be 0. And now we can come in here to the outflows, and we can put that request in as a request. That's the name of the column too, by the way. So we'll put that in here as a request. Pond 2 request. Okay, it's just a request. It's not the flow. right? This is not the flow rate necessarily. And the reason I say that is because we're just defining the pump capacity with no regard to how much water is currently in that pool. The nice thing about a pool is that we allocate these requests. So if we have a higher priority outflow, it will come first. So that's the beauty of having these priorities in this element. Now we can make use of GoldSim's functionality instead of us having to be in charge um, of keeping track of those kinds of things. It is a uh, much less error prone approach. And so now that that's done, we can go to the outputs of the pool and see in our outflows, we have 2 pond 2. That is the flow. That is the actual flow that will then be passed over to the other pond. And so we can just simply refer to it. Now it's true, we could pass it through an expression if we wanted to, and so forth. I'm not really going to worry about that. I don't feel like it's necessary for this simple model. So I will go here to the inflows and I'll replace the old one with the new one. I'm going into the outflows and finding that particular flow and passing it over. And now when I come back up, you see there's this influence line. If I double click on it, it shows me that I have the pool. And in fact, down here would be the best place to start. The output element is the pool from pond 1. The input is going to the pool of pond 2. That all checks out, makes sense. If I look at the specific outputs and inputs, it's the pond 2, it's the 2 pond 2, and then it's the going into the second inflow of the pool in pond 2. Um, if we don't like that name that we're giving it in the outflows, we could call this supply to pond 2, or we could call it pump to pond 2, something like that. Anyway, when I double click on this influence line, you can see that there's the name I just assigned it, pool dot pump to pond 2. Okay, so then we could also give this a name, and this is pumping, something like that, and then delete this one because we're not using it anymore. And so now, now we can see how, let me move some of these lines around. There we go. And now I can relink the flow. I'm not going to link to the request anymore, right? I'm going to link to the actual flow that's in here in the outflows, pump to pond 2. Okay, so now we can run the model and look at the results, and you can see that it's about the same. There are going to be a couple of differences, and we could get into why those are differences. But what you will see here is that we have drained pond 1 all the way, and the reason that happened is because we did not have the min function in there anymore. Personally, I don't see a problem with that, but if you did need to maintain a minimum level, then we would need to program that in there. But the point is that we are first supplying water to evaporation and losses before we send water to pond 2. That is the important point that I need to make here. Um, so yes, we do have some flows going over to pond 2 when the pond 1 is empty. However, we did make sure that we first allocated water for evaporation and seepage losses in that pond before we sent water over to pond 2. So with this, I think we have a much better visual representation of what is happening between these two ponds, and this will be able to carry you forward in larger models and make things a lot easier to understand. And I hope this is useful for you. Um, Please, as usual, please let us know if you have any comments or questions, feedback. We do always appreciate feedback on these videos. So good luck with your modeling, and stay tuned for the next video.